Hi all, so we will continue on the application of differentiation. Okay, so we have discussed these two applications, which are rates of change and gradient of curve at a point. And now we will continue with the third application, which is local and absolute extremum. Okay, the motion along a straight line will be discussed on the next week. So this is the learning outcomes for this topic, for this part. So at the end of this topic, students should be able to find the critical points of a function and determine the nature of the critical points. Okay, now look at this graph. Okay, so from this graph, you can see the 3 points there, and we call that 3 points are local minima. Okay, meanwhile, we have this point as the absolute minimum. Okay, we will only have one absolute minimum for each graph. Let's consider the maximum point. Okay, so we have many maximum point there. Okay, we have local maxima, and we only have one absolute maximum. Okay, so this is the difference between local maxima and absolute maximum. So the terms used in general, we have extremum is a general word for either maximum or minimum. And if you have extrema, extrema is the plural form of extremum. Okay, so the maxima or the minima is the plural form of maximum or minimum. So on the graph in figure 1, there are many points that can be considered as the local extrema. But when it comes to absolute extremum, there can only be one absolute maximum and only one absolute minimum. Okay, so we will begin our discussion with finding the local extrema. Okay, and there are two methods available, which are, the first is by using the first derivative. Okay, and we call as the first derivative test. And second method is by using the second derivative, and we call as the second derivative test. Okay, so this is the basic characteristic of an extremum. Okay, given y equal to fx. If the function has a minimum or a maximum at x equal to c, then either f prime c equal to 0, or in other words, the slope of that function at x equal to c is 0, or f is not differentiable at c. Okay, thus c is called a critical point. Okay, so from this, if you have f prime c equal to 0, so we can find the value of c. So we can have c, which is the critical points. Okay, and some notes will use stationary points. It's actually this, it's just the same, which is we will have f prime c equal to 0. Okay, what does it mean by f prime c? So what you need to do is you need to differentiate fx with respect to x. Okay, and we set it as 0 to find the point c. So we start with the first derivative test. Okay, so we begin by analyzing slopes of a function around local minimum and maximum. Okay, consider the graph of y equal to fx. Let the function has a minimum at x equal to c. Okay, we know at exactly x equal to c, the slope is 0. Okay, hence, what about the slope of the function at values of x before and after c? Okay, so let's consider the observation. So the first observation we have, when x is less than c, the tangent line has a negative slope. When x greater than c, the tangent line has a positive slope. And we have at exactly x equal to c, the tangent line has slope 0. So we can summarize the information in the table. Okay, so when x equal to c, okay, this is the sign of f prime x. So this one you will get 0, because to find the critical points, so we need to find f prime, we need to have f prime c equal to 0. Okay, so we take any value of c but it's less than c, sorry, any values of x but it's less than c. Okay, and we have the negative value here, and for x greater than c we have the sign of f prime is positive values. Okay, so if you have this situation, so the extremum point, okay, will becomes minimum. All right, let's discuss by graph. Okay, for example, we have this one. Okay, we have somewhere here, this is our c. Okay, this is 0. Okay, we have this one, the tangent is 0, something like that, when the slope is 0. Okay, so if we have less than c here, okay, it's less than c. Okay, here it's less than c. If you have the negative sign of fx, so f prime x is the slope or the gradient. So if you have the negative slope, so you will have something like this. Okay, so when x is less than c, you have the negative slope, and meanwhile for x greater than c, you have the positive slope. So positive slope, something like this. This is slope. So that's why you will have this point is the minimum point. Okay. Alright, let's look at the observation 2. Okay, we have when x equal less than c, the tangent line has a positive slope. When x is greater than c, the tangent line has a negative slope. And at exactly x equal to c, the tangent line has slope 0. So we can summarize the information in table. So if you see here, okay, when x is less than c, you will have the positive slopes. Means that you have, okay, as x increase, y also will increase. And when x greater than c, you will have the negative slope. So you have like this. Okay, when x increase, y will decrease. Okay, so if we combine this thing, okay, this slope, and we have this one as 0, so you will have the maximum point. Okay, all right, so this is the theorem 1, which is first derivative test. So if f prime changes sign from positive to negative as x is increasing through x equal to c, then fx has a local maximum at c. Okay, meanwhile, if f prime x changes sign from negative to positive as x is increasing through x equal to c, then the fx has a local minimum at c. Okay, if f prime does not change sign as x increasing through x equal to c, then fx does not have a local maximum. Alright, so let's look at this example. Okay, find and classify the extrema of the following functions if they exist. Okay, we have 3 functions there, so we will try to solve all these 3 functions and to find and classify the extrema. So we start with question A. Okay, fx equal to x squared minus 4x minus 1. So to solve this, the first step is to differentiate fx. Okay, which we will have f prime x is equal to 2x minus 4. Okay, so this is the first step. Next, second step. Okay, we set f prime x equal to 0. Okay, and this is to find the critical point. Okay, so when we set f prime x equal to 0, so we have 2x okay, 2x minus 4 equal to 0. So you will have 2x equal to 4. So x equal to 2. Alright. So this is our x. Okay, or our c to the critical point. So this is the x. So we can find y by substituting x equal to 2 in the function of fx. Okay, so you have 2 squared minus 4 times 2 minus 1. Okay, which is equal to 4 minus 8 negative 3. 4 minus 8 negative 4 minus 5. Sorry, minus 1. So you will get negative 5. Okay, so this is the values of y. So we have the point 2, negative 5, where x is equal to 2 and y equal to negative 5. So step 3. Okay, so step 3, we need to classify the point whether it's maximum or minimum. Okay, so how to classify that? Alright, so we have just now the x value is 2, so maybe we can put in a table. Okay, somewhere here, let's have this one, 1, 2, 3. Okay, so this is f prime. So this is our c. Sorry, this is our x equal to c, which is equal to 2. And this one we have x greater than 2. This one x less than 2. Okay, and this is sine of f prime x. Alright, so we know that when we substitute x equal to 2, okay, we'll have f prime 2 is equal to 0 here. This will get 0. Okay, we use this derivative. Okay, we substitute x equal to 0. So now let's consider another point which is less than 2. For example, I took x equal to 1. Okay, which is less than 2. So by substituting x equal to 1 in this equation, okay, so you will have what? 2 minus 4, you will get negative, right? So you will get negative 2. So the sign here will be negative. Okay, and on the right side, we have x greater than 2. So when we have x greater than 2, we choose any point. For example, we have 3 here. Okay, so if you substitute the value of x equal to 3 in the f prime x, so you'll have 6 minus 4, which is equal to positive 2. So you will have the positive sign. Alright, so we have this table, and from this table you can see that we have this one. Okay, when we have the x is less than 2, you have the negative sign, so this is the negative slope, and when it's greater than 2, you have the positive slope. Okay, so therefore you can have a conclusion which is it's a minimum point. Okay, so conclusion that we can write as okay, the point to -5 is a is a minimum. Alright, so this is for A. So we continue with the second question. Okay, second function fx equal to x cubed minus 3x plus 1. Okay, so step 1 is differentiate. So you have f prime x is equal to 3x squared minus 3. Okay, so this is the f prime x. Okay, and then step 2 is to set fx equal to 0. Okay, or we have 3x squared minus 3 equal to 0. Okay, so from here you will have we can find x. Okay, we have 3x squared minus 1 equal to 0, so we will have x squared equal to x squared equal to 1, so our x is plus minus 1. Okay, so we will have two critical points here. Okay, which is one is x equal to positive 1 and another one is x equal to negative 1. Okay, right. So so the critical points are right when x equal to negative 1. Okay, you will get y equal to 4. This is by substituting x equal to negative 1 into the function of fx. And also when you have x equal to 1, so your y will be negative 1. Okay, so since we have two critical points, so we need to construct two tables. Alright, where first is x equal to negative 1 and another table is for x equal to 1. Okay, so for x equal to negative 1, so we have here this is x equal to negative 1, this is x greater than negative 1, this is x less than negative 1. Okay, so here we have 0. Okay, so if we substitute x with something that less than negative 1, for example, I choose x equal to negative 2. Okay, so we have this one, f prime x just now, so you can have f prime negative 2 is equal to 3 times 4 minus 3, so just you will get 12 minus 3, we get 9 here. Okay, so you have positive value here. Okay, and if you choose x greater than negative 1, for example, I choose x equal to 0. Okay, so let's say you have 0 here, so f prime 0, so you will get negative 3, so the sign is negative. Okay, from here you will have the positive slope and the negative slope, so this will become the maximum point. Okay, alright, so we have a conclusion which is negative 1, 4 is a maximum point. Okay, so let's proceed with x equal to 1. Okay, so we construct the table here. Okay, this is x equal to 1, this is x greater than 1, this is x less than 1. Okay, and now we have at x equal to 1 you have 0, the f prime. This is f prime x. Okay, and when you have x less than 1, for example, you have x equal to 0. So we have found before f prime 0 is equal to negative 3. So we put as negative. Okay, and another one is for x greater than 1. So for example, we choose x equal to 2. Okay, so you'll have here f prime 2. So you will get what? Okay, you will get the same answer, right, which is 9. Okay, so you will have here positive. Okay, so you have negative and this is positive, so this will become the minimum point. Okay, and therefore we will have the conclusion, which is 1, negative 1 is a minimum point. Okay, right, this is the solution for B. Okay, so can you solve this exercise? Find and classify of the extrema of the following function if they exist. Okay, so solve this by using the first derivative test. So next part we will continue with the second derivative test. Okay, so that's all.